Welcome back to Science Online. My name is Rajesh. Titrations. This video is for GCSE chemistry students, higher tier, and also is very useful for A-level chemistry students too. Today we're going to discuss about titrations. What is titration? What is the purpose of the titrations and calculations involving titrations? So let's start. Imagine you've been given some hydrochloric acid in a conical flask and you've been asked to find out the concentration of this acid. The equation for concentration is concentration equal mole over volume. So in this case, you can work out the volume of the hydrochloric acid just by pouring it into a measuring cylinder. You can get the volume. But how do you work out the mole of this acid? This is where titration comes handy. What is a titration? This is a process where you react the unknown substance with the known substance. In this case, hydrochloric acid is the unknown substance, with the known substance in order to work out the mole of this unknown substance, hydrochloric acid. Let's see how this works. In this example, the hydrochloric acid is the unknown substance which we're trying to find out the mole of it. See, the common reaction within the acid is the acid-base reaction. The well-known base is a sodium hydroxide we can easily find in the laboratory. So you need to get the known concentration of the sodium hydroxide. When you carry out the titration, the unknown substance goes in the conical flask. The known substance, in this case, is the sodium hydroxide, goes in the burette. For this purpose, the sodium hydroxide we are using has 0.05 mole per decimeter cube concentration. It's a known concentration. And the volume of the hydrochloric acid we are using in the conical flask is already been measured. It's 0.15 decimeter cube. When you start the titration, we add the sodium hydroxide from the burette drop by drop until the end point. You can repeat the titration several times to get the mean. This will avoid anomalous readings. At the end, the volume of sodium hydroxide used to titrate this 0.5 decimeter cube of hydrochloric acid is 0.27 decimeter cube. Now write the equation. Sodium hydroxide reacts with the hydrochloric acid in 1:1 ratio to form sodium chloride and water. And write all the details underneath in a clear format. The concentration of the sodium hydroxide is already known, which is 0.05 mole per decimeter cube. The volume of the hydrochloric acid is 0.15 decimeter cube. And the volume of sodium hydroxide we have used in this titration from your burette reading is 0.27 decimeter cube. So we have all this information underneath our equation. Now, for sodium hydroxide, we got the concentration and the volume. Therefore, you can work out the mole of sodium hydroxide using concentration equal mole over volume. So the mole of sodium hydroxide is 0.0135. Since the sodium hydroxide and the hydrochloric acid reacts in 1:1 mole ratio, the mole of hydrochloric acid also 0.0135. Now we got the mole of hydrochloric acid. Since you have the mole of hydrochloric acid, go back to the equation. Concentration equal mole over volume. Mole is 0.135. Volume is 0.15 decimeter cube. And therefore, the concentration of the hydrochloric acid is 0.09 mole per decimeter cube. In titration, you probably noticed you are dealing with lots of numbers compared to reacting mass calculations. You've got volume, concentrations, moles with the different reactants. Therefore, it's very important when you do these calculations, under the equation you have to bring all the numbers in a clear format. So you won't confuse with the different numbers. If you follow the format, you don't have to go back to the questions and pick up the wrong numbers and using in the wrong equations. Hope you find this video useful. Until I see you in another video, bye to you.